Okay, so number 3, introduction to quadratic functions and models. Number 1, we are going to define my function as a x squared plus bx plus c. Okay, so the condition to do that is that a, b, and c are real numbers. So any number can be a, b, and c. The square give you information that the it's not going to be a line, it's going to be a curve called parabola. Okay, so also this one, the a, is called the leading coefficient. So we're going to call it like this, the leading coefficient. And the condition for that are going to be when a is greater than 0, so the parabola is going to be open upwards. When a is less than 0, the parabola is going to be downwards, like that. This is going to be a happy face, and this one is going to be a sad face. Okay, if I am going to do a parabola here, so I'm going to graph a parabola, any parabola. So the condition for that is, so I will have, let's do a parabola like this, so in this situation I will have this point, very important point, is called the vertex. Okay, the vertex has a coordinate called 1 y vertex, and this one is the x vertex. Okay, so the coordinate for the vertex are x vertex comma y vertex. Okay, so then the other two important points here is the zeros. So this 0 and this 0 here. Okay, so this one and this one are the zeros. So we call those zeros x1 and this one x2. So in this situation, the parabola cuts the x-intercept, and this is called x1 and x2. Very good. And then finally, we have an axis of symmetry here. So because the parabolas are symmetrical shapes, so then we have, this is called the axis of symmetry. The axis of symmetry. Very good. How we are going to calculate x1 and x2? If you remember, we have a formula for that. And the formula x1 and x2 is going to be equal to minus b plus minus square root of b squared minus 4ac divided by 2a. Now, we know computers are doing the job for us, but we are going to find or calculate one here for showing what is going on. Okay, very good. So the conditions to be a parabola are going to be explained by this factor here. Okay, the factor inside the radical. This piece of information here. Okay, so we call this one the discriminant. Okay, so the discriminant of the parabola, so which is going to be equal to b squared minus 4ac. As you can imagine, this number under the radical here can be three different possibilities. Okay, I am going to say that the discriminant can be greater than 0. If it's greater than 0, so I have a real number here. So I can calculate the square root of any real number. So in this reason, the result of this one is two real numbers as zeros. I have two real numbers as zeros. So I have x1 and x2. No problem with that. x1, comma, x2. The situation, is this one. So I can see the two numbers here, x1 and x2. The other possibility is the discriminant can be less than 0. So it's going to be a negative number. In this situation, we are confronting two imaginary zeros. Okay, I will explain this one. So we will have x1 and x2, but this is going to be an imaginary number. And finally, the discriminant can be equal to 0. For this situation, we have also two real numbers, two real zeros, but this is called multiplicity. It's a very multiplicity 2. This is a very unique situation when the discriminant is equal to 0. So you have two real zeros, which actually is only one zero, but the number here is going to be in repetition. In other words, for this particular situation, if I have my graph like this, the parabola is going to touch one point and going on. So this number is going to be a real number, but in repetition. This is multiplicity 2. Okay, so it's a very weird situation when you have something like this. When you have two imaginary zeros, the parabola is not going to cut the x-intercept. So it can be like this or can be like this. Okay, this situation is also very common when you have two imaginary zeros over there. Okay, so and I will give you a couple of samples about situations with the discriminant. Okay, so how are going to be those situations? Okay, situation number 1. In situation number 1, let's go with this one. I have a parabola like this. In situation number 1, like this. So I can see my two zeros. So the discriminant here is greater than 0. How is going to be A? Well, A, because the leading coefficient, remember, is going to be a happy face, right? So when A is greater than 0, and this is a happy face, so then greater than 0. See, this is situation number 1. Situation number 2 is a situation where we have something like this. A parabola like this. As you can see, my parabola is not intersecting my x-axis. So discriminant has to be less than 0. And A, because this is a sad face, has to be also less than 0. Okay, let's go here. I have a space to work over there. So I will do like this, situation number 3. In situation number 3, I have my graph like this. The parabola touch and going up. So touch 1 point. Discriminant is equal to 0 and A, because this is a happy face, greater than 0. Situation number 4. In situation number 4, I have the opposite situation than number 3. So my parabola is going to go and touching and going down. So I have 1 point of touching over there. Discriminant is equal to 0, and A, because this is a sad face, has to be less than 0. Very good. So situation number 5. For situation number 5, so we have this one. For situation number 5, so we have a parabola cutting both axes. As you can see, the discriminant here is going to be greater than 0, because I have 2 real numbers as zeros, and A, because this is a sad face, is going to be less than 0. And finally, situation number 6. For situation number 6, I do my parabola over there, and the discriminant, as you can see, is not, my parabola is not cutting, so it's less than 0, and A, of course, is greater than 0. So those are the 6 situations that you can have with your parabola, okay? So next class, we are going to start calculating, because I think it's too much, and today is enough, and we are going to stop the movie here. Thank you.